Hey, welcome back to the channel where we talk all things engineering, technology, and finance. Before getting into today's content, make sure you hit the like button below and don't forget to subscribe to the channel so that way you're up to date on all the latest content that we post to our channel. And lastly, make sure you share the video with friends and family. As I always say, we don't want to hoard the knowledge for ourselves and we want everybody to learn. So let's jump into today's content.
Welcome back to another engineering video. In today's video, we're going to talk about what an oscilloscope is. Now, if you're wondering, we have one right over here. Looks like a lunchbox with a bunch of knobs and a bunch of different things, if you can see that in that corner there. But it's really weird where you have this just box with a bunch of knobs. What does it do? One thing that I've noticed throughout my career or just even life in general is that if you're trying to explain a topic to somebody and you can't explain it in very layman's term, then chances are you don't really know the topic that well. So this is going to be my attempt to explain to you in simple terms what an oscilloscope is and what we use it for. So let's jump into it right now. As engineers, we work with different tools in order to create products and services that you guys see today. For example, if I'm a software engineer and I'm writing a piece of code, let's say for example, I'm writing code in C. If I'm writing a C program and I need to see what my software is doing, software engineers have tools available to them that allow them to see what the software is doing. So let's go on the computer and take a look at an example of what a tool may look like that gives you the eyes or the visibility to see what your code is doing.
Here we are on my desktop where I have two things in front of you. I have the terminal, which we're going to be running our code. And the second thing I have in front of you is a code that I wrote in C. And this is a program that basically says hello. And the goal is to test this out and to see if it works as intended. The intended result is to say hello a total of 4 times. But let's run this program and see what we actually get. As you can see in my terminal, based on the results, this program doesn't work as intended. The intended goal was to make sure that it says hello 4 times, but instead we're saying hello 5 times. And we see that because it says, this is my 0 times saying hello all the way to 4, right? 0 to 4 is 5 times. So what can we do in order to view what is happening with this program? Sure enough, there are tools available to software engineers that give them the ability or their set of eyes to see what's happening at the software level. So let me launch one of those tools and you can see exactly what that is. So here's the tool that we need in order to debug our program. We can see what's happening with our program if we just point it exactly on the program itself. And this tool will help us debug our program and tell us why it's not happening 4 times instead of 5.
Just joking with you guys, not that tool. You don't need actual sets of eyes to see the software. But let me actually show you what real software engineers use. And here's an example of one of those tools, and it's called GDB.
And as you can see here, GDB is launched. Now with our program up in GDB and we see all the lines of code, what I'm going to do is I'm going to add a breakpoint or a location in which we stop in order to analyze why this program is printing out 5 times instead of 4 times. We can do break, and let's put it on line number 6 in order to stop at the printing of hello. And then what we can do is we can run the program. So we ran our command a few times and we see here that we're able to print hello. We have 0, 1, 2, 3. And then we finally come down to the next part, which is 4. And that's where number 5 is happening, right? 0 to 4 is 5. So using GDB now, I'm able to see that I is happening 5 times. And it's because I is less than or equal to 4. So let's go ahead and make our change and get rid of the equal sign. We can go ahead and compile the program again, and we're gonna run it. And as you can see here, hello is printed to the screen 4 times instead of 5.
Now that we've seen an example of what software engineers use in order to see what the code is actually doing, what about hardware engineers? When you're a hardware engineer and you're developing hardware in order to do a particular function, what tools do you think we use in order to see what our circuit is doing? What is our set of eyes? And if you guessed the oscilloscope, you are absolutely correct. So the oscilloscope, which is right behind me, is a tool that we use in order to see what our circuit is actually doing. So let's take a look at a quick example. So in my hand, I have an FPGA development board. And essentially it's a blank chip, or the FPGA, and we have to program it to do a special function. So I'm gonna program this now in order to do a special function. And it's basically gonna be a simple function. And all it's going to do is it's going to send out 2 square waves. One square wave that is going to be 1 second long in a pulse, right? So it's gonna go high for 1 second, it's gonna go low for another second, and then we're gonna replicate that and do another pulse, another square wave, and we're gonna do high for 5 seconds and low for 5 seconds. So let's program the board now, and we're going to actually take a look at how we use the oscilloscope to see if this is actually doing what I told it to do. So let's jump into programming. With power applied to the FPGA development board, let's go ahead and program the FPGA. And we see here that it's programming. The FPGA is done programming. Only problem is, as you see here, how am I supposed to see what the FPGA, which is this chip over here, what is it doing? And that is the beauty in where the oscilloscope comes into play. And we're gonna make connections from the oscilloscope to the FPGA development board in order to see if our chip is doing what we programmed it to do. Let's turn on the oscilloscope.
Our oscilloscope is going to take some time to boot up. Once it's done booting up, I'm going to take you into the interface where we can take a look at the signals that we are capturing. Here we are on the interface of the oscilloscope. And as you can see, the oscilloscope is acquiring the signals that we're connected to. And we can see that because channel 1, which is the yellow signal, is on, and channel 2, which is the purple signal, that is also on as well. So one of the things that we're going to take a look at is we're going to take a look at both signals separately. And the one signal, which is going to be channel 1, our yellow, is going to be a 1 second square wave. And you're going to see it high for 1 second and low for another. So let's take a look a little bit closer as I fix the signal here for us to see a little bit better that is actually the case. So as you can see here, we have 1 second per division, right, per line. And you can see that the signal goes high for 1 second, and then immediately it goes down and it goes low for another second. Now let's take a look at the second signal. Same thing here, 1 volt per division. And as you can see here, we are going high for 5 seconds, right? Because there's 5 different divisions at the high, and then immediately we go down and we go low for 5 seconds as well. And we can see that our signal is actually working as intended. And we can see based on the oscilloscope that what we programmed the FPGA to do was to generate a square wave at 1 second high, 1 second low, and generate another square wave at 5 seconds high and 5 seconds low, that is actually the case. And the oscilloscope verifies that. And this tool is the eyes for electrical engineers, so we can see what is happening inside our circuit.
We just took a brief look at what an oscilloscope is and how it provides hardware engineers the ability to see what's inside of their circuit. And it's basically our eyes into what's happening. And without that tool, we really could not be successful in creating the products and services that you see around today that requires some form of hardware development. So if you're interested in more videos on engineering or even technology and finance, stick around as we'll be uploading more to the channel. And more importantly, make sure you hit the like and subscribe button as well, and turn on the notifications so that way you get notified whenever we upload new videos to the channel. And I'll see everybody on the next video.